Download this code from codegive.com, link in the description below. Resolving Java Classpath Confusion, a comprehensive guide with tips, tricks, and code examples. The Java Classpath is a fundamental, yet often frustrating, aspect of Java development. Understanding how it works and how to manage it effectively is crucial for avoiding errors like class-not-found-exception, noclassdeffounderror, and other dependency-related issues. This guide provides a deep dive into the Classpath, exploring common problems, practical solutions, and best practices. 1. What is the Java Classpath? The Classpath is a parameter passed to the Java Virtual Machine, JVM, that specifies the locations where the JVM should look for class files, .class, and other resources, like property files, images, etc., when running a Java program. It's essentially a list of paths to directories, jar files, or zip files containing compiled Java code. Why is it important? Finding classes. The JVM needs to locate the class definitions, the .class files, for all the classes used in your program. Without a properly configured class path, it won't be able to find them. Dependency management. Java projects often rely on external libraries, dependencies, that are packaged as jar files. The Classpath tells the JVM where to find these libraries. Resource loading. The Classpath is also used to locate non-class resources, such as configuration files, images, and data files that your application might need. 2. Common Classpath-related problems and errors. Class-not-found-exception. This exception indicates that the JVM couldn't find the class file for a particular class, even though the application tried to use it. This is a common error when the necessary jar file is not included in the class path or the class path is not correctly configured. noclassdeffounderror. This error is similar to class-not-found-exception but can be more insidious. It means the class was available at compile time but not at runtime. This often happens when a required jar file is not present in the class path when the program is executed, or when versions are mismatched. No such method error. This error occurs when the JVM tries to call a method that doesn't exist in the loaded class. This usually indicates an incompatibility between the version of the class file available at compile time and the version available at runtime. This is frequently a class path problem where an older version of a library is being used instead of the expected version. Illegal access error. This error happens when your code tries to access a class, method, or field that it doesn't have permission to access. While less common, incorrect classpath configurations can contribute to this error by causing the wrong version of a library to be loaded, leading to access restrictions. Version conflicts. When multiple versions of the same jar file exist in the class path, the JVM might load the wrong version, leading to unexpected behavior and runtime errors. This is especially problematic in large projects with many dependencies. Class loader issues. Java's class loading mechanism can be complex. Using multiple class loaders or custom class loaders without proper configuration can lead to class path issues. 3. How the class path is set. There are several ways to specify the class path. Classpath or CP command line option. This is the most explicit way to set the class path when running a Java program. You provide a list of directories and jar files separated by a platform-specific delimiter, semicolon on Windows, colon on Unix-like systems. Classpath environment variable. You can set the classpath environment variable to define a default classpath that will be used if the classpath option is not specified. Note: while using the classpath environment variable might seem convenient, it's generally not recommended for managing project-specific dependencies. It can lead to unexpected conflicts and make it difficult to maintain consistent environments. Use project-level ClassPath configuration instead. See IDE and Build Tool sections below. Manifest file, jar file. Jar files can include a manifest.mf file within them. This file can define the ClassPath attribute, which specifies additional jar files that should be included in the ClassPath when the jar is executed. This is useful for self-contained applications. IDE, Integrated Development Environment. IDEs like IntelliJ IDEA, Eclipse, and NetBeans provide graphical interfaces for managing the ClassPath of your projects. They allow you to easily add jar files, directories, and even dependencies managed by build tools like Maven or Gradle. Build tools, Maven, Gradle. These build tools use dependency management systems to automatically download and manage dependencies for your project. They configure the ClassPath based on the dependencies declared in your project's configuration file, example pom.xml for Maven, build.gradle for Gradle. This is the recommended way to manage dependencies for non-trivial Java projects. 4. Practical tips and tricks for resolving ClassPath issues. Double check the exception message. Pay close attention to the exact error message, example the fully qualified class name in class-not-found-exception. This will tell you which class the JVM couldn't find. Verify jar file existence. Make sure the jar file containing the missing class is actually present in the location you expect. Typos in the file path are a common cause of ClassPath problems. Inspect the ClassPath. Use the system.getProperty, java.class.path command to print the current ClassPath at runtime. This can help you identify whether the necessary jar files are included and in the correct order. Check jar contents. Use a zip tool, like 7-zip, or the jar.tf command to inspect the contents of a jar file and verify that the missing class file is actually present inside the jar. Dependency management tools are your friend. For all but the simplest projects, use a dependency management tool like Maven or Gradle. These tools automatically handle dependency resolution, downloading jar files, and configuring the ClassPath, significantly reducing the risk of ClassPath-related errors. Clean build and rebuild. When you make changes to dependencies or ClassPath settings, always perform a clean build and rebuild of your project. This ensures that all class files are recompiled and that the ClassPath is updated correctly. In Maven, use mvn clean install. In Gradle, use Gradle clean build. Order matters. Sometimes in general, the order of entries in the ClassPath can affect which class is loaded if you have multiple versions of the same class available. The JVM loads the first class it finds in the ClassPath. Be mindful of the order of dependencies, particularly when using a dependency management tool. Use IDE features. Your IDE provides valuable tools for debugging ClassPath problems. Use the IDE's debugger to step through your code and see where classes are being loaded from. Many IDEs also offer ClassPath viewers that show the entire ClassPath hierarchy. Avoid wildcards. Generally, while you can use wildcards, in the ClassPath to include all jar files in a directory, this is generally discouraged. It can lead to unintended dependencies and ClassPath conflicts. Explicitly list the required jar files instead. This is particularly important when using modularized applications or working with specific versions of libraries. Watch for transitive dependencies. Dependency management tools automatically handle transitive dependencies of your dependencies. Be aware that adding a single dependency to your project can bring in a whole tree of other dependencies, potentially leading to conflicts. Asterisk manage versions carefully. Asterisk always specify the versions of your dependencies in your project's configuration file, example pom.xml or build.gradle. Use version ranges with caution. Explicit versioning helps prevent unexpected behavior caused by different versions of libraries. Asterisk isolate environments with containers. Asterisk for complex projects with many dependencies, consider using containerization technologies like Docker to create isolated environments. This helps ensure that your application runs consistently regardless of the underlying system. 5. Code examples. 5.1. Basic Classpath example, command line. Let's say you have the following file structure. main.java. My library class.java, inside my library.jar. First, compile the code. You'll need to compile main.java with mylibrary.jar on the class path. This will create main.class in the src/com/example/directory. Now, run the main class. Replace with, on Windows. This will execute the main class, which depends on my library class from mylibrary.jar. The output will be. If you omit lib/mylibrary.jar from the class path, you will get a noclassdeffounderror because the JVM won't be able to find my library class at runtime. 5.2. Using Maven for dependency management. Create a pom.xml file. Then, in your Java code, you can use classes from the Apache Commons Lang library. Maven will automatically download the Apache Commons Lang library and add it to the class path when you build your project. 5.3. Using Gradle for dependency management. Create a build.gradle file. The Java code is the same as in the Maven example. Gradle will automatically download the Apache Commons Lang library and add it to the class path when you build your project. 6. Best practices for class path management. Use a dependency management tool. Maven or Gradle are highly recommended for managing dependencies in non-trivial projects. Explicit versioning. Always specify the versions of your dependencies in your project's configuration file. Avoid using ranges unless you have a very good reason to do so. Isolate environments. Consider using containerization technologies like Docker to create isolated environments for your applications. Keep dependencies up to date. Regularly update your dependencies to the latest versions to benefit from bug fixes and new features. Be sure to test after upgrading dependencies. Minimize dependencies. Only include the dependencies that your project actually needs. Unnecessary dependencies can increase the risk of conflicts and make your application larger. Regularly clean and rebuild. Perform a clean build and rebuild of your project whenever you make changes to dependencies or class path settings. Document dependencies. Maintain a clear and up-to-date list of your project's dependencies. 7. Debugging techniques. Print the class path. Use system.getProperty, java.class.path, to print the class path at runtime. Use a debugger. Use your IDE's debugger to step through your code and see where classes are being loaded from. Enable verbose class loading. You can enable verbose class loading by adding the verbose class flag to the Java command line. This will print detailed information about which classes are being loaded and from where. In conclusion, mastering the Java class path is essential for building reliable and maintainable Java applications. By understanding the concepts, common problems, and troubleshooting techniques outlined in this guide, you can effectively resolve class path issues and focus on writing great code. Remember to use dependency management tools, specify versions explicitly, and keep your dependencies up to date to minimize the risk of classpath-related errors.